Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about electrochemical machining or ECM, not EDM, ECM. So let's dive deep into it. So basically, what are the requirements that ECM can do, not EDM? Basically, what if you require mass production, as in like thousands of something has to be made? Meaning, what does this technology offers? No tool wear. Meaning, if you made a master system, it will last for very ludicrously long time. You do not have to worry about it. So that's a desirable thing. Second, there are certain most scenarios you do not have to worry about it. So do not give that, oh, I have never had to worry about it. Of course, there are many scenarios where a metal alloy or a super alloy does not give a damn about surface finish and if you have a heat affection zone on it. But some do. There are certain scenarios where it's like, that's a no. Once the metal has been forged, you do not want to do that again. So, okay. Study the chemistry, study metallurgy, and they're like, there's a whole field of it. Most of the time you do not have to worry about it, but sometimes you do have to worry about basically any changes that you can introduce to it. For example, if you're using thick metal, cutting through laser, that edge will get harder. Now, like, isn't that good? Well, that also makes it shatterable, so you may not want it. So there are changes that happens because of heat that you may not want. And again, if you have a process that is literally falling lightning on it, it might create micro cracks, which may not be an issue in day one, but may become a big ass issue after some time. So micro cracks, which is residual stress, putting some stress into the part, may not be acceptable. So let that be okay. This is a very niche requirement, but it is a requirement. For certain scenarios, shut up, take money. They will pay you extra if you can make sure these things are not an issue. So that is there. And you need surface finish, meaning you need smooth. And I mean smooth, meaning gases should flow on top of it. Water, liquid, fuel should flow on top of it like there is nothing, zero friction. You need smooth, and you need the smooth in one go, because again, technically you can achieve smooth finish from anything as long as you have steps for it. Like you have a CNC, you do roughing pass, then you do finishing pass, then you send it to a tumbler and go, and then you have a final part. You can do everything. It's just that, what if you want all of that in one go? Part, the answer. No finishing, no polishing, smooth. Smooth. So that's the whole thing. And ideally, you should be able to support complex shape, meaning you have like S curve, Y curve, Z curve. You should be able to handle it. And you should not be picky about the material. Basically, EDM also has this advantage, like it's not picky. CNC is surprisingly picky. Earlier, I used to think once you make it rigid enough, you can just work on it. It's like, no. Like if you have to work with armored steel, yeah, it's a completely different ball game. If you want a steel that can like a CNC machine that can handle those sort of high grade, high toughness material, ooh, it's not that it can't be done. It's just that write a very big blank check, like big and blank check. So if you want to deal with super alloys, yeesh, so there are certain requirements, and you can see EDM is literally falling lightning. So it affects it, and thankfully liquid is there, so it does not have too much warping or anything. But some alloys are so finicky that their property will change. It may not be an issue, but it may be an issue. In that scenario, that is a no-go scenario. And again, EDM does wear down the tool. The wire is a consumable. Even when you are making the plunge cut with the drill will wear down. The mold, they will wear down. So if you have to make thousands of this part, not desirable. And surface finish, while good, not that good. So here comes ECM. Now, ECM is electrochemical machining. Basically, you dissolve a conductor. What conductor does not matter. You dissolve the hell out of it, meaning it can work with almost same things, same portfolio of things as EDM. And ECM utilizes conductive solution, meaning here water is not acting as a barrier like how water is acting as a dielectric in EDM. It's acting like a conductive. It's completely different. You basically take water and you put salt in it. Now, yes, you can do with normal table salt, but generally based on alloys, people select the right amount of salt. So, or like the right composition of salt. So you have water plus salt. Basically, you have a GG amount of conductor there. And the tool, the machine tool that is going and doing things, that will be negatively charged. We classify as cathode cutting. So cathode will do the work, and your positively charged, basically your work piece will be eaten away, so to say. And the fluid is basically carrying the metal hydroxide away. Now, water is kind of necessary in this sort of system. I've barely seen, some people are working on like some acid and all that, but those are rare. Not unheard of, it's just rare. Most of the time you electrolyze the water, that creates the hydroxide that eats away the metal and flushes it away. So you take the basically liquid, you pull it into a container, filter it out, pump it again. So that's how it works. Now there is no heat generation. It's not cooling it, there is no heat generation. That's the best part about it. And physical action is not done on the part, meaning there is no stress. Like what if you cold roll it, what if you do this and all that, all of those have stresses. This puppy has zero stress. It's like it does not care. It's like you just eat through it, like eats through it. And because it's a liquid that is doing the actual, not lightning, it has almost the same property, better property than what EDM. EDM has the advantage. What if there was a burr that will attract far more lightning, so that gets kaputted very quickly. But again, it's a very rough process. It's a rough process. Here, it's atomic level erosion. So anything that sticks out more, like a surface that is not perfectly flat, will become a flat because of the fluid dynamics. So this puppy achieves a surface finish that is like, ooh, like flat out. This, if you are not achieving right surface, there's a good chance your tool has that. Like your tool is imparting it, because it's good. When people say about like this puppy is good, it is good. Meaning like take the part, use it. That's how good it is. Meaning a rifling barrel, take it and go. Take it and go. Maybe add coating if you want to have certain resistance against corrosion. And again, that's for the metal. If the metal is like, I can tank it, nobody cares. It's like, etch it, go. So that's the ECM process. Basically, you have negative that is doing it, and it will not erode. That's the benefit part of it. There is nothing that happens, no deposition, no erosion on the negative part. Everything happens on the positive part, and liquid facilitates it. So there is no wear and tear on the tool part, meaning the tool can last for thousands of cycles. Now, of course, you are still talking about water, you're still talking about physically moving it, so it will drift out of spec after a while, but it's like so long that like you don't have to worry too much about it. And the liquid itself, because most of the what we call metal hydroxides, they precipitate, meaning they do not mix that well, so filtering them out is also not too difficult. You do have to filter the water, it has to be kept in a sweet spot. So the machine itself is not that huge, but the water filtering part is huge. So there goes the ECM part. Now the tool aspect of it is normal CNC. It's almost same thing, computer numeric control. If you can make a CNC, a 3D printer, you can do this. That's not an issue. And again, because this technology is able to create very high precision, you should have a CNC that is precise enough. It's like if the mill itself is not precise enough, the output will not be precise. So you basically make a CNC, bake with precision, but you have the benefit. There is no physical force. It's not like there is no ringing. Like making a lathe that can make a part, that's easy. Making a lathe that can make a high precision part on a hard metal, ludicrously expensive. Like it's so expensive, the machines, the automated lathes, many times they have literal casting, concrete casting or sand casting inside their structure, so it does not resonate. Again, action equals reaction. There is no action equals reaction in this, meaning if your structure is stable enough for 3D printing, it's good enough for this. So precision achievement is not that difficult, although every part of this system has to be corrosion resistant. And I do not mean basic corrosion. Like there are grades of stainless steel, like which are like, meh, it can handle some outdoor environment too. No, this puppy can tank it. You need something that can tank it, because this has corrosive liquid. This has more corrosive than salt water in the sea. And again, you also have electric field, so you have to be mindful. Everything, every part of it has to be designed in such a way that it can tank the corrosion. Otherwise, the machine will eat itself in months. So corrosion resistance does matter. And liquid circulation, same thing. Filtration and pH management and all that, normal basic stuff. There is no force and there is no heat generator. That's the good part. That's why even the liquid itself does not evaporate very quickly, very slowly, so to say. And what about the power supply that is creating the electric field? Yeah, that is a bit tricky. And again, tricky for common public, not for companies. It's a high amperage, meaning you can easily start with 100 amps, 1 kilo amp, 2 kilo amp. That's the highest I saw. I could easily find some, I'm damn sure there are companies that are working on higher than that, but 2000 amps is the highest. And what about the voltage? Thankfully, very low. This generally does not even cross 30. And yes, you can work with, what if I want to use a computer power supply? Can you use that 12 volt high amp capacity? Of course you can. It will be just slower. And again, when people are working on final passes or like making something very smooth, they generally reduce the voltage. Like single digit voltages are used, like 8 volt, 9 volt. So Voltage is not an issue, meaning you can touch it and still will not get shocked, and assuming you do not have a cut. Your skin is supposed to stop anything below 50 volts, and if you are below 30 volts, unless you are like dropping your tongue, you should not be fried. And generally it's DC. Most of the time it's just raw DC. You do not have to do switching, but some designs do utilize pulse, but it's rare. Not unheard of, it's just that not necessary all the time. So it's rather simple. The tool wise is rather simple, finicky, messy and corrosive, but simple. So are they utilized? Well, they are not as common as EDM. If I say EDM, there is 90 people who are like, yeah, I have worked with it. It's just that when I say ECM, is only 9 people have worked with it. So ECM is rare, let that be very clear. However, it does have its own ecosystem and dedicated use case in sectors, whereas like this sector only deals with this. It's just like you do not have to, I'm like, if you're poor, you deal with other stuff. But if you are in this sector and you're dealing with it, you generally deal with ECM, not EDM. So for example, barrel rifling. There are scenarios where what if you hammer it, what if you do all of that? And there are reasons why those work, but you have to select alloys that are suitable for that. For some reason, certain systems do not like it. I do not know the precise metallurgy, but there are use cases where people are like, no, we'll pay extra money for this machine because it does not do any hardening, extra hardening, surface hardening, because again, the whole property as you casted the metal, it's one. The more stuff you do to it, the optimum property will dissipate. So people generally use this sort of thing. And again, the barrels last very long, and smoothness matter. Smoothness matters a lot because again, the better the gas sealing, the more efficient it would be. So barrel rifling, bladed disc, blisk as it's called. It's now the hotness thing where people are like, hey, compressor stage. I'm not talking about the turbine stage. Compressor stage, right now we have turbine blades and those are rooted into the disc. What if instead of having two parts, what if you have one part? And benefit is your engine performance can go up by 5% and weight reduction could be very significant. For example, F-35 direct takeoff variant has this blisk into it. How do you machine blisk? Can you do that with EDM? Yes, but it will have way too many stages. This puppy is like, I got you. Air will flow through me. No issue. Smooth. 6th gen fighter jet engines are made from this. So yes, European Union is working on it, and that's how I got the footage. So basically blisks are like surprisingly well suited to this technology. Like you generally make it out of titanium or something like that to keep the weight low. You force that titanium and then you just machine it. You do not change its property, you do not react to it, and you get smooth finish. So there are certain scenarios. And fuel injector, rocket industry. So you cannot even find a single footage of it because again, ITAR regulations and all that, but it is utilized there. And it's preferred wherever you have something, it's like, no, surface finish matter, including human augmentation. So basically things, medical implant. Why? Well, the finer the surface, the less bioagitation will happen. You do not want things to be poking out because that's where the bioagents will attack it. Basically, your own immune system will fire missiles at it. The smoother the surface, less rejection will happen. Like, it's a big deal. So you want to make sure that your body does not reject the stuff. So finishing matters. And generally, if you are dealing with some finicky material that has to avoid basically heat effect or cracks, micro cracks, this is one of these very critical scenarios. Now, let that be very clear. The machines are very expensive. The technicians who can deal with this is also very expensive. Not because it is expensive, because it's rare. Like availability, like inherently, it's actually simpler than EDM. It's just that it's so rare, so few people know this. It's like they can charge whatever you want. And if you have to use this process, you have to use the process. You will pay for it. Like again, you can see that the whole blade can be machined in one go. One go. So what can we expect in the future? Well, here's the deal. It's not a popular tech, but it is an important tech. And for certain sectors where it's like, bro, shut up, take money. Like you have defense, aerospace, medical implants. I'm reasonably sure all of you should understand the importance of this. So it's not hard or complex. That's the good part about it. It's like its power supply is much simpler than EDM's power supply. So it's not complex. And again, it's also loadless. It's not creating action equals reaction. So it's messy, but it is doable. Low popularity makes it hard to research. Meaning it's like, hey, I want to etch this, pew metal. I do not want to use that exact word, but that metal is like, okay, there is a specific salt for it. Do you know what salt it is? it's hard to research. All the information is available. It's just that you hard to research and all that. It is doable in DIY context. A lot of people are trying to bring this because inherently it's simpler than EDMs. EDM just have a lot of popularity, so people are actually actively working their ass off to make sure EDM can come down to same prices like, you know, high-end 3D printer like $3,000 or $2,000. This in principle can be much cheaper than that. It's just that it's not popular enough. So that is there. However, let that be very clear. When I said that does not wear down the tool, this is utilized by our country's people. There is a country, real world. There is a country. In that country, there are two groups of people, and this in power group of people are like, what if I shift delete this group of people? So they went shift delete because they were not American. They did not have pew pew, and they did not understood why you need pew pew again. So they're like, okay, what to do? So they 3D printed it. Okay, 3D printing pew pew works. It's just that without barrel, it's not that useful. How do you make the barrel? Okay, steel pipes are not that difficult. Cool, got it. How do you barrel it? How do you make the rifling in it? Ta-da! ECM. And once they figured it out how to do that, they started to mass produce it, the barrels. And like, okay, it will not hold up to military grade pew pew hairstyle. In guerrilla tactics, things equalize surprisingly quickly. And they are coming to delete you and they are expecting you to be naked. And you are like, no, I can poof you. And what they are doing is like, poof, collect your stuff, downshift my 3D printed stuff so they can use for training, which again, far more priceless. Use this for training. I use the actual hard metal stuff for the next PPU stage. So real life reality check. This is how important this technology is. So let that be very clear. This is not something that's like conditional, if this, then that. Nah, real life utilize. And again, how did I figure out this technology? America, pew pew. That's the most cases. Like in America, ask anything that goes with a pew pew. They're like, sir, this is a research paper. We have more research paper. Like, sir, take it and go, sir. Not even paid for it. Just take it and go. So that's how I figured out. Like, and again, big barrels. And the machines are selling, it can work with like, you know, 0.22 LR rounds to 20 millimeters. The hell is doing 20 millimeters? But again, normal stuff, America. So it is an important technology, let that be very clear. Now, and the best part about it, fluid and the tools, they are not that consumable. Meaning, yes, they will evaporate eventually, they will erode eventually, but it would be so slow that like for getting started, it's not even a concern. It's not like EDM wire where you have to keep buying spools of it. So, or like a drill pipes, you have to buy a lot of them. That's not any case here. So there is genuine use case and advantage that this technology has that other technologies do not have. So this was my presentation on ECM. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.